everyone, and thanks for joining us for Data Engineers Lunch number 54. Today we have software engineer Obi presenting on Dbt and Spark today. And the co-organizers and organizer for this event are Rahul Singh, Arpan Patel, and myself. And we are always looking for members, speakers, and sponsors. So if you or someone you know is interested in joining our discussion here, or potentially even speaking at a Data Engineers Lunch, definitely feel free to reach out to one of us. Our emails are listed there on the slide. Try contacting me first if you don't get a hold of me, Arpan, and then lastly, Rahul. We are a part of a larger community. Data Community DC is a diverse and inclusive culture that encourages and supports and celebrates people of all races, religions, sexual orientation. Everyone's welcome here, and we expect respect to be given to those classes. You can find out more about Data Community DC at their blog, as well as some of their upcoming events listed at those sites there. What we cover here is everything related to data engineering. So that could be sources to end user enablement and everything in between. We've discussed a lot about ETL, data wrangling itself, kind of new technologies that empower data engineers to better do their work. So if there is a technology or something you're versed in or well-versed in, or someone you know is, and you'd like to present at one of these discussions, feel free to reach out to one of us. If anyone's new and would like to introduce themselves and what they do with data, feel free to do so. I'm going to keep moving through the intro, but I can pause if I see someone kind of wanting to introduce themselves. Group rules: if you have a question, please ask it. Be polite and courteous to others. And this is meant to be a discussion, so share what you know. Obi will kind of go over his ground rules of how he'd like questions to be fielded or comments. But yeah, feel free to contribute in the chat as well. Here or not, we deal with real-time data platforms and analytics on a daily basis. And this is something we're happy to provide to the community, is these kind of webinars introducing different technologies, different ways to do ETL or data wrangling, that sort of thing. DataStax is a partner, as well as George Washington University and some other program sponsors and organizational sponsors are listed here as well. And if anyone has any jobs, meetups, hackathons coming up that they would like to promote, you can feel free to use this as an opportunity to do so. And Anant is hiring. Full-time or part-time positions are available for data platform operator, engineers, or architects. You can connect with us at careers.anant.us. And this is a weekly webinar, takes place every Monday at 12 Eastern, and we have the sister lunch, Cassandra.Lunch, that also takes place at 12 p.m. Eastern time on Wednesdays. Stay tuned for an announcement. We are going to be changing this format sometime in the course of 2022 to cater to a more global audience. So these times may be subject to change. Just be sure to stay posted. We'll probably make an announcement on anant.us/events once that the details of that are nailed down. With that, I will go ahead and pass it off to Obi to present today.
All right. Give me a second. So, as you heard, my name is Obi Anant. I'm a data engineer here at Anant. Today, our topic is Dbt and Spark. We'll be talking about data build tool. We'll be talking about connecting it to Spark and using it to do transformations. Generally, I prefer to take questions in the chat, but if we are at an intermediate point in the presentation, say going between sections, moving between the slide deck and the demo, that sort of thing, feel free to unmute yourself and ask and add anything if you have anything at that point. All right. So DBT has come up in a couple of other lunches that we've given. I believe it's come up once during Cassandra lunch and once during the Data Engineers lunch, but we've never really gone into it in detail. So this will also be a sort of overview of DBT, but it's mostly come up in association with other, data warehouse technologies or BI tools or that sort of stuff. And there's reasons for that. So overview: DBT is a transformation workflow tool that lets teams collaboratively develop and deploy analytics code. And you get access to stuff like CI/CD for your transformations. Basically, DBT performs in-place data transformations within your data warehouse that you're already using. And here by in place, I mean it stores both the result of the intermediate steps and then your final resulting data into tables in that same data warehouse. And it uses projects that are composed of YML files and SQL files. So you don't actually have to code up any of your transformations like if you were using an ETL tool. A lot of those require coding, whereas this is more like writing, writing queries in SQL or whatever. And then generally, it uses those files to build a DAG of simple transformation steps that combine to create a full pipeline. So DBT comes with a bunch of adapters. DBT core is maintained by DBT Labs, as well as the adapters for Postgres, Redshift, BigQuery, Snowflake, Spark, Databricks, and Presto. There are also others maintained by the teams that create the software themselves, and then also some community maintained adapters for connecting to different tools, different data warehouses, and BI tools. DBT, you use a profile to connect to your data warehouse. You have one profiles.yaml file. It can hold all your different profiles, but when you run a project, it only takes the one that you've set as target. Each adapter has different requirements for its profile, depending on how you connect to the underlying data warehouse. And then multiple profiles can be stored. Oh, I already said that. Multiple profiles can be stored in the YAML file, but it only uses the one that's set as target. So we can see an example profile here. This is for Postgres. So obviously the type is Postgres, but it also takes information like host, username, and password, ports if you change your Postgres port, how many threads DBT is allowed to use when setting up and doing transformations there, things like timeouts, et cetera, and all sorts of auth options as well. And like I said, you can define multiple of these in your file. So you can have one connection to Postgres, one connection to Spark. But when you run your project, only the one set as target will actually be used to connect to whatever data warehouse you're using. So that means that DBT does not do extraction or loading, purely does transformation. All right, DBT projects. You create a project every time for your different transformations. It contains a main YAML file, the project.yaml file, and it tells it about the directory, structure of the project, and the configurations for your project, and then also your models, which are SQL files that define your transformations and then the relationships between those transformations. You create a project and a project directory using dbt init command and provide a project name. It creates an empty project with some basic, they're basically tests. It sees if it can actually connect to your data warehouse by trying select one, essentially. So DBT models. Each model individually is a single select statement. They're defined in SQL files, like I said. Usually those go in your models directory, but they can also go into subdirectories there. The name of the file is used as your model name, and then it also defines the table that is being stored into afterwards. You can nest your models in subdirectories, like I said, but you can also make them depend on one another. In this case, we're building, in this example here, the customers table from STG customers and STG orders. All right, so moving on to DBT and Spark. So the DBT Spark adapter connects to your Spark SQL tables, as long as they're not temporary. And it performs transformations in place, saves the results into new tables, your intermediate tables and your final tables, depending on what you set up your transformations to do. And Spark with DBT has 3 possible connection methods. They're actually stored in 2 different libraries. You can install Spark with ODBC. You can install DBT Spark connector that uses ODBC, and you can install the one that uses PyHive. And then the PyHive version of that includes the connectors for both HTTP, the managed service, if you're using like Databricks Interactive Cluster or another managed service that just gives you an HTTP endpoint to talk to your cluster. You can use the HTTP connector or adapter in order to talk to your Spark cluster. Or if you have a thrift server on you're running on the lead node of your cluster, your cluster itself can be either hosted locally, it can be on premise, it can be in the cloud. So the one we'll be using today is the thrift connector. But if you have a Databricks, a normal Databricks cluster, you connect to it with the ODBC adapter. All right, I'm going to be moving on to the demo now. The demo is actually 2 parts. To do sort of an overview, we're going to use this repo to do a short example with Postgres on Gitpod. This is the one that's easier to follow along with if you would like to. And then I'm going to do one locally for the actual Spark connection. And the reason for that is because Gitpod recently changed the way it does connections, and it manages ports and does connections. And that means that Spark installs work differently inside of Gitpod. All right. So this is the repo. I've already started up the Gitpod. It takes a few minutes because it's using a specific it's using a specific Docker image, the Postgres one that Gitpod provides, so that it has a Postgres install and the ports for that already open. And then also what we're doing is we're installing requirements, specifically Sassel has in order to install DBT properly, you will need to have this new version. So we install that. And then the one that we're actually using here is pip3 install DBT Postgres. All right, and what we start out with in this repo are, so this is adapted from a provided example that uses seeds so that it can load data directly from CSV files. What we're actually going to be doing is we're going to load those CSV files into Postgres, and then we're going to run the DBT project as normal without seeds. All right, so step 1, we're going to go into Postgres. I'm going to create a database. No, we're going to use the database that's already there, which is Postgres. So instead, we're going to start by creating our user. Make sure that they have privileges on Postgres. And then we're going to run dbt init, call it and as you can see, when you create a project, it gives you an option of which database you're using. In this case, we pick Postgres, and it creates us our project directory. And what we're going to do is we're going back here to edit the profiles page. And the way this works, threads we'll set to 1. Running this locally, so host is localhost. The default port for Postgres is 5432. And then we give it the user we created for this. Password. And we have to make sure that it's using the correct database name. And then we also are going to hand it the default schema name. All right. And we can test our connection with dbt debug. As we can see, we are in the correct directory, so it can find the profiles.yaml page, or no, so it can find the project.yaml page file, and then make sure that the profiles.yaml page is in the correct space, which is, user/.dbt/profiles.yaml. And then it also tests, 1, if you have access to Git, and then 2, if you can actually connect to that database. And in this case, we were able to, so we're good to move forward. The thing that we are going to do now is actually put that data in the tables. So if we look at the data for a second, you can see that the customers page is an ID, first name, last name. And then that the orders are ID, user ID from the customers table, order, date, and status. And then the payments table is ID, order ID from the orders table, payment method, and amount. And what's actually going to happen when we run our transformation is it's going to combine those so you have a single table with a sort of, it's a customer view that tells you information about that customer's orders and about the payment for those orders. All right, so first thing to do is create our tables. We're creating staged tables, which will be the preliminary location of our data. A lot of DBT assumes that you have a data warehouse in place. Like I said, these commands, like the basis for this is a tutorial where they teach you using seeds. And so those are the two options for getting your data into DBT. Pretty much every connection method will be using data already set up in a data warehouse like this. And we're going to use copy commands to copy those CSVs into tables. All right. Make sure that we have data. Yep. All right, so the next thing to do is to look at our models. So generally, what this first one, these are the default project models. All they do is, select one as ID from your data source. So they're basically just doing the same thing that the connection does. There's not any real processing going on there. But the models that were provided Oh, wait, these all got put into example. So we'll go in models here. Whoops. So now it will actually separate our folders for us. So basically what happened there was the models folder that was already there only had one directory with any files in it inside. So the S code collapsed them together. All right, now going over our new models. So we have our schema.yaml file that tells us about the data. And then we have these model files. So basically, this uses a seed, which is why this comment's there, and this ref. But essentially, it's just selecting your data. There's nothing really special there. We're going to modify this to actually refer to the table that we have, which is public.stgd customers. I'm going to have to do that for all of these basic files. The others refer to the intermediate tables that are created, which aren't changing, so those don't need updates. But we will take a look at them in just a second. All right. So our intermediate definitions are customers and orders. So those three original create from, in this case, our STGD tables. It creates the STG tables. Generally, it's from the files themselves. It pulls and transforms those, and then you get these tables in Postgres. And then our future ones, the ones that we're looking at now, our customers and our orders transformations. Those model files will refer to that loaded data. So you define all your terms essentially, and then the final result is a single query. In this case, select star from final. But everything before that is just defining your terms in that query. And then for orders, we have similar thing. It uses staged orders and staged payments in order to, create with a little bit of processing a final result. So we can go back to our main project directory. You need to be in the project directory when you run dbt run, just like you do when you need to, when you run dbt debug, because it will check for that project.yaml file, and if it doesn't find it, it won't be able to run your project. So we can call dbt run, and we see that it ran the preliminary, the example transformations as well, even though they don't really do anything. But we see those succeed. And then we also have the views that we created in Postgres. The STG customers is an intermediate one, whereas public.customers is one of our finals. And then we can go back into Postgres. And I think we have to be. It's a view on a table that we don't have access to. Well, we can't see the data, but we can confirm that it has created all of the intermediate tables and then the final views that we wanted to see. So moving on again, we're going to start the Spark portion of the demo. This is a good time for questions if there are any. The first step is going to be starting up Spark. So we downloaded Spark binaries 3.20 with Hadoop 3.2. And we're going to be starting a master node. Going to that master node to get the definition from Spark master. We're going to start a single worker, which requires this as an argument. And then we're going to start a Thrift server, which will sit in front of that and manage Spark SQL. So I've already installed Dbt Spark on this environment, but it's essentially the same command you saw in the git pod docker file here, which shows that we're using the PyHive version of the package. And then we're going to be using the Thrift connection, which we will set up in, well, just a second, because I want to use Beeline to set up our tables in Spark SQL. And then we're just going to create a username. And we're not going to create a password. And look at our default. See if that'll work out. No. We got to go in and drop the tables. Okay. Wonder if I can just say drop tables. Nope. Okay. So we'll do it individually. Sorry about this. This is all remaining from when I set up this demo, and you know, it's not proof of it running if you know, all the data is already there. So just going to go ahead and drop all our tables one by one. Whoops. I keep hitting the wrong button. Give me the tables again. And then this time I will actually hit the semicolon button.
Obi, is there like a drop namespace command?
I don't know. Okay, yes, that's at least working. So,
Comment in the chat said you could drop database, drop database public.
yeah, no, that was the first one I tried. And it says it won't work because database public is not empty. So we'd have to figure out a way to force it or go through like we're doing now and drop the tables on purpose. This is probably another good time for questions because this is just going to be by rote. I spelled that wrong. Or is this one a table and not a view? Or a view, but not a.
Could you not utilize the autocomplete potentially? I don't know if the
Yeah, no, it's not a. I think it works for keywords, but not table names. All right, now which of these will be tables and which of these will be views? Yeah, same issue. It won't drop a database as long as there's still data in it. Sorry. Actually, no, I should leave that. So what we're going to do, that one, deleted customers, because we're just going to copy that data back in. Okay, yeah, so what we're left with is our three tables: raw customers, raw orders, raw payments, created from those CSV files. Going to back out of the Spark folder. Create our project. Use the Spark. All right, and in contrast to the Postgres one, which just creates your profiles.yaml and leaves you to fill it in later, the Spark, at least the Pi-Hive version of the Spark adapter, actually asks you to fill in your profiles.yaml as you're creating the project. We're using Thrift authentication. The port for the Thrift server is 10K, 10,000. The schema that these are in is public. I'm just going to give it one thread to work with. And if we run it out, we can see that it's created our profiles.yaml for us. There are some alternative options, a username and password that you can also provide, but in this case, we don't need them. This one will be sufficient. So we go back into the tutorials folder, make sure that our connection is good. Yep. And then because we've already, well, I put all the models in miss. So we're going to cp-r miss/models into our project directory. And then just like before, it requires us to go in and edit the select from statements. In this case, we're pulling from public.raw customers. Public.raw payments. Public.raw orders, just because that's how we set up our tables in this one. So now if we dbt run, it'll perform our transformations. And we can go back to our Spark install. Where are we now? Beeline. Oh, we didn't actually connect back to our Thrift server. So now we can see we have all our tables back again. More typos. There we go. Now we can actually see that what it's done is it's associated customers with their first order, their most recent order, their total number of orders, and then customer lifetime value is derived from the amounts derived from those orders. So DBT is sort of meant to be used to prepare your data for things like BI tools, or to do analytics in place that can be done. It is like the way it connects to Spark isn't that you can use Spark's processing engine to do arbitrary transformations on your data. It's just connecting to Spark as a data warehouse, like it connects to all the other data warehouses, and then using your queries and your definitions in order to perform transformations that you can put together into a pipeline. So in this case, we have our intermediate tables, STGD orders, things like customers, all those intermediate tables that build up so that you can then perform queries and do the math to get this table. How large was the total data set? Do you know the performance compares to alternatives? So this data set was small. The amount of customers they have is something near 100, and only slightly more than that orders and payments. So really we're working with a very, very small data set. It's only 300, 400 rows total. And as for performance, I am not sure compared to using something like the ETL tools that we talked about in the Python series. I think that several of those will probably have better performance just because the way they process data, they can do better parallelism, they can do GPU processing if you need to, all that sort of stuff. Whereas I don't see options like that for DBT. I think what's the way that you're supposed to use DBT is to have all your transformations set up into sort of incremental steps that you can also use, and just have that go off every so often when you get new data in or something. As non-GUI ETL tools, would DBT have any advantage over Airflow other than better SQL language use? So not really. So the advantage of DBT is that you can use CI/CD to maintain your pipelines. DBT does the actual processing, but it can't handle arbitrary processing. Whereas something like Airflow, unless you wrote all your transformations in Python directly, it's better at sending out for other tools to do the actual processing. What was I about to say? Yeah, I don't usually see Airflow specifically as an ETL tool, since it's not built really for the processing, it's built for the scheduling. But other than that, I don't know really how comparable they are.
Well, I guess a question off that is, I'm doing a quick look up here, but
Mhm.
from Airflow perspective of like orchestrating like your ETL process, like it looks like there are ways to integrate Airflow and DBT, but say you have like some sort of pipeline, right? That if you're not using Spark and you're doing some kind of data transformation that DBT can handle, is there like functionality? Like, would it make sense to like orchestrate DBT and data transformations with Airflow in your pipeline, or would that scheduling ability like be better off suited just wherever you have running DBT on?
Well, DBT doesn't really handle any of the scheduling by itself. You run the job and it does all the steps in sequence, and it respects your DAG, your dependencies, but essentially it just gets you your final project. So there are potentially ways you can use DBT to with Airflow to do that processing, which would essentially be having Airflow and other tools manage your extraction and your loading process, and somewhere in between you call DBT run to do the transformation. But if you're already using Python tools or whatever that will load data into a Python program for processing, I don't see that there's much advantage to putting DBT in the middle when you could use something more like pandas or something. Load your data into pandas directly, transform it, and store it wherever you want.
Gotcha. Thanks.
So this data all came from CSVs and then you combined it. Does DBT support like other data formats?
So DBT is meant specifically for connecting with data that's already in a data warehouse, which is part of why we did all the copying before.
Oh, gotcha.
There are ways that you can, see the seed functionality that allows it to load in CSVs directly. I believe that works with CSVs. It can work with Parquet files and maybe a couple others. But it's not really how you're supposed to be using DBT.
Gotcha. It would be outside of its prescribed use case, I guess, if you will, to be like trying to load your own files into it.
Yeah, so this is sort of like the talk on Pygram ETL, which is that it's for people who already have a sophisticated data warehouse set up, and it's to help you in managing and transforming your data in that specific use case.
Gotcha. Thanks, Obi. Does anyone else have any other questions for Obi? Looking into YouTube, I'm not seeing any questions there either. Oops. Does not seem like I'm seeing any more. We have 5 minutes left till the end of the hour. Thank you, Obi, for your presentation. Whenever you're doing a demo, like hate when you accidentally like mistype or some typos seem to come out and stuff like that. I definitely commiserate with you on that one. But thank you everyone for coming out for another Data Engineers Lunch. Obi, another great presentation and demo. Really well articulated and able to answer all the questions. So we'll give everyone 5 minutes of their day back and enjoy the rest of your Monday. Thanks, guys.